So today I'll be providing a bit of an overview of the Toowoomba Second Range Crossing project and how 12D model, 12D synergy has been implemented on the $1.6 billion road project. I'll be covering a bit of a project overview, a bit on our 12D snippets, a little bit on how we've implemented 12D synergy on the project, and a bit of a summary. The Toowoomba Second Range Crossing project is the largest Commonwealth Government commitment to a single road project in Queensland's history, addressing a recognised constraint in the land transport network. As you can see here on the picture, the land transport network goes right through Toowoomba CBD. So all the trucks and connecting the ports to markets have to actually go through. So with the Toowoomba Range Crossing going around it, it will provide a much needed second range crossing in this region. It will provide a safer, faster and more efficient route for connecting freight to major ports and markets, significantly improving driver safety and community amenity by removing the heavy vehicles from within the Toowoomba CBD. In August 2015, the Commonwealth and state governments awarded the contract to design, construct, operate and maintain the Toowoomba Second Range Crossing project to Nexus Infrastructure. This consortium consists of the Plenary Group, Sintra, Ashiona, Forever Agriman and Broad Spectrum. Ashiona Infrastructure Australia and Forever Agriman are in a construction joint venture for the design and construction of the project, whilst Broad Spectrum are responsible for operating and maintaining the toll road for 25 years. Oricon and WSP Parsons Brinckerhoff constitute the APB TSRC joint venture, and they're providing the design services for the project. So a little bit about the project. The bypass road is situated to the north of Toowoomba. It's about 41 kilometres in length and starts at the Warrego Highway in the east, travels through to the Gore Highway in the west via Charlton. There's 4 lanes from the Warrego Highway east interchange through to the Warrego Highway west interchange, and then a further 2 lanes connecting through the Gore Highway. So there's multiple grade separate interchanges along the road. There's the Warrego Highway east. This is the start of the project. There's a system interchange that allows traffic to continue onto Toowoomba or connect to the 41 kilometre toll road. About halfway along the road, we come to our first interchange at Smart Street. It's a simple diamond interchange with dual roundabouts effectively, and connects to the New England, allows connection to the New England Highway and to Toowoomba CBD. We come along Warrego Highway West, again is another diamond interchange, and this is at the end of the 4-lane section and provides the vital connection through the existing national land transport network. So a lot of freight will be going out through the existing Warrego Highway and bypassing the city. We have Toowoomba Cecil Plains Road. This is on the 2-lane section of the road. Again is another diamond interchange and provides connection to the Wellcamp Airport and Business Park. Gore Highway is the end of the project and provides a simple interchange connection at Athol and completes the expansion to the National Land Transport Network. So on the project, there's approximately a 30-metre deep cutting through the top of the range. This will allow all heavy vehicles, including dangerous goods carriers and over-dimensioned vehicles, to basically use the Toowoomba Second Range Crossing without going through the CBD. New England Highway, which obviously will be relocated to a new structure that actually connects over this cutting. On the approach to this cutting, there's an 800-metre viaduct in fairly challenging conditions, so it's fairly impressive as you head up the range. 12D version 11 was used to design the roads, earthworks, drainage, public utility plant and all other miscellaneous civil works across the project. To manage these disciplines, the project was effectively split into 4 key areas. So we had an east, a central, a west and a local roads. So that was all our returned works to the local councils and the TMR. During the tender, 12D version 10 and decisional templates were used to design the road. However, with the release of version 11, the old decisional templates were retired for snippets. So the snippets allowed us to insert decisional-like strings to create the benching, but with the full flexibility of being able to change the grade, width, slope individually. Being a very large earthworks project, this was extremely important to allow individual modification without the need to develop a new decisional template each time. So the designers it's a two-step process to insert the benching on the project. It's first of all, we insert the first snippet, and this prompts the user for a variety of parameters, if you like, to define the geometry. So here we have it whether it has a table drain or not, and all the cut and fill slope widths, slopes, etc. Now this can be applied for the whole alignment, or it can actually just be applied for a particular cutting. From here, the user will then modify that benching because it's actually an overbuild. It builds past the existing terrain. And the second part of the snippet is the actual trim. So we then trim the benching back to the natural terrain using a couple of minor parameters of cut depth, fill depth, and when to invoke sort of shallow and deep decisionals effectively. So there are still decisionals in them, they're just a little bit smarter with snippets. This typical section's by far not the largest on the project, but shows how sort of extreme some of the earthworks are. So, and this goes for both cuts and embankments on the project. We had challenging conditions on both sides of the Great Dividing Range. So we had the very steep terrain on the eastern side, and then it's very flat and some not so great black soil to work with on the western side. So having the ability to modify each individual bench as required, so for better stability, when we hit not so great soil, we're able to lay them back and then steepen them back up without a problem. We had a few other snippets on the project. So we had a concrete barrier snippet. This effectively prompted the user for the barrier type, whether it had lighting or didn't have lighting. Now this varied just the top width of the barrier. Had a variety of string selections, backstop, behind the barrier, and any verge transitions that were required. So the concrete barrier shown here is not that snippet. This one's a little bit more complicated because it actually takes into account the varying slope of the carriageway or the difference in slope and varies the slope of the concrete barrier. Now, it again is a two-step process, but a little bit more complicated than the standard insert. We had guardrails for pretty much the entire length of the project, and to get these to be inserted readily was a must. So we again built a small snippet that gave the option for the user to define whether it was tri-beam or W-beam. Gave the option to define the terminal type, so type 1, type 2, whether we had connection to a concrete barrier. There's a variety of drop-down lists to choose from. Again, it prompted for the control line, string selection, a few parameters, and then the snippet instance. So this is pretty important feature of the instance. It allows us to actually overlap the guardrail as shown here in the picture, because without that, it wants to do all sorts of crazy things. Both the concrete barrier and the guardrail snippet were actually inserted on different layers, and that just allows us a bit more flexibility with the formation of the road without having to worry about the guardrail snippet, and allows us then to manipulate the road and let the snippet do a little bit more manipulation where required, so modify the verge behind it if required. So you can see there's a verge width of 1.2. That would actually, if the verge was only a metre, it would push it out to 1.2 for us where we inserted it. Another snippet we had on the project was the emergency stopping bay you can see here. Again, there's a number of string selection, and we had the string selections in all our snippets, effectively because as we went down the different control lines, we did actually have unique string names based on the actual control line numbering. So if it was on a 0-0 control line, it obviously started at 0-0, 01, 02. And if it was off the 10 alignment, it would go 10, 11, 12. So we had a unique naming system that allowed us to actually identify strings depending on where they were. This snippet again prompts you for the length of the barrier. Again, string selection, string shoulder widths. It also had an important value inserted for the shyline offset. This is particularly important where we have guardrail and concrete barriers. It allows us to actually taper the rate inside and outside the shyline differently. So if it was inside, we'd go 1 in 30. If we were outside, we'd steepen up to 1 in 15. It just shortened the barrier. Again, all these snippets are available to be applied forwards and backwards on the control line. We had a snippet that inserted our structures across the project. So it's nothing fancy, it's quite a simple snippet. It prompts the user for a bridge number, control line. It gave us the ability to have a varying deck wearing surface and slab thickness, even though most of those were fairly constant, but also gave us a structure depth. Now this allowed us the ability to actually have soffit strings, and from the soffit strings we were able to put a bridge clearance and actually check our roads to this bridge clearance. So pretty easy to set up and very, very important for the road designers and quick to see where you have your clearance. So a few other snippets. We had an entry ramp snippet. Now, again, similar to what Steve talked about yesterday, it passes through a few parameters through. So this particular one passes your design speed and your travel time. Now that's great if you wanted to calculate the exact length to 4.5 seconds of travel time if you want a particular length, but we also have the ability to manually override that lane length, which became important down the track as we wanted to extend our lanes. Again, applied forwards and backwards and a variety of string selection to allow us to actually insert it. The exit ramp snippet is exactly the same as the entry ramp snippet in that it actually calculates the length required based on the speed and the lane width. This gave us the ability to actually modify it as needed, but again, we found sometimes if there was a sight distance requirement, it was very hard to muck around with the design speed when you wanted to lengthen it, so we overrode a manual auxiliary lane length where required. So both snippets utilise the start and or end of the control line. So as the interchange moved or lengthened, the entry ramps actually got longer or shorter as required as well. And both snippets gave us the ability to add additional line marking or shoulder run out where required. We had a variety of other snippets across the project, probably over 20 overall, and they varied through minor modifications through to different merge or sight distance requirements. So they basically gave us the ability to achieve a consistent modelling technique across we had at the peak probably about 10 different road designers through a few offices. So, and it basically saved us time on having copious amounts of modifiers. If you were to expand those open and look what's in the back end, they're doing a lot of work for you. So when the tender was awarded, APB came together to brainstorm different IT architectures that would be able to handle and deliver the large-scale multidiscipline project. For the first time on a project, 12D Synergy was considered as a software platform that could help manage 12D model data. At the time, neither Oricon nor WSP Parsons Brinckerhoff had implemented 12D Synergy, but within 2 weeks of approval, we had 12D Synergy server set up and was using it on project. This was a huge benefit in the early days as the project office wasn't quite set up, but it gave us the ability to start the design from our different home organisations. So with a simple, secure custom logon, the users from APB can access the Toowoomba Second Range Crossing project data from any office, coffee shop or bedroom with an internet connection, and also have the ability to take the data offline. 12D model data, the portability meant that scaling up and down the resources for the project was a huge benefit, as we didn't have to worry about office space or actually data sharing. So we didn't have to copy data sets and give them to users in other offices or try and recount where that data had gone at the different times. So At the peak of design, we had project users in our project office. We had both home organisations in Brisbane and regional offices in Toowoomba, Cairns and Newcastle using it, and we still do in some of those offices still. The all 12D users on the project had full access to the one and only data set, so that's the important part. So no copies of data sets, and it was accessible as if you were sitting in the project office. So there is a slight warning here. You have to have a fairly good internet connection with large data sets. So, and you can imagine with 41 kilometres of survey, aerial photos and design data, they're fairly large. So a good internet connection is a must. We currently have over 35 advanced data management users. So, and they use 12D Synergy to manage 12D model data, any of our ArcGIS information, Autodesk Navisworks and Civil 3D, and our XP Swim Friends. We have over 85 standard users, and they're using 12D Synergy effectively just for managing emails. So we have all our documents in ProjectWise and all our AutoCAD drawings in ProjectWise, but our modelling side of things are all done in 12D Synergy. And we currently have over 170 12D model projects having been created and stored within our database. So this is a bit of a look at our actual setup. It's fairly simple. We have 6 main folders: 12D, Civil 3D, emails, GIS, Navisworks and Swim. So if we expand these open a little bit further and get into the 12D, you'll see that we've broken it down by discipline. So we've got our drainage, erosion and sediment control, environment, geotech, ITS, PUP, roads, structures, any external data we're supplied to the client, to the project, and our survey folder. If we explore the roads directory a little bit deeper, you'll see that's then broken into our 4 key areas. So we've got an overall east, central, west and local roads. So, and here, each 12D model has a unique alphanumeric code. And this code is effectively gives us identification of the project, which is also passed on to the control line and all the design strings. So wherever you are in the project, if you select on a model, you can actually find out where it's come from and effectively has a unique identifier. The great thing about Synergy, as you can see here, you can actually see who's in the project. So on a network, that's incredibly tough. It's you're always finding out who's where. Here it's a simple expansion of the folder and you're away. The great benefit of having 12D Synergy was the ability to set up notifications. Now this is extremely important when you're working in multiple offices, as you're not often sure when the next guy is going to be out of a project or checks in or out of project. So I have notifications set up on a few key folders to see if anyone checks out the survey without knowledge, and vice versa. Checking in master projects is also important. One of the key things that took us a little while to learn with 12D Synergy was the fact that we, in the early days, we'd do a design, we'd check it all back in, thinking we'd done a great job, and then we'd forgotten to actually share models or tins. And for us, in the early days, we'd check the project back out, we'd share them, and then check them back in. It wasn't a while until we figured out that you could actually do this sharing from within Synergy without opening the project. So it's a hidden little gem, and it's a huge time saver, because often quite the case when you've checked in a project and forgot to share out a model or tin. And by far the biggest benefit of 12D Synergy so far, I think, has been the history. So every time you check a 12D project in or out, it has the history. And we encourage all our users to have a detailed history log where possible. As you can see, Brendan's checked this project in over 165 times at this state. So, and he does a very good job at actually putting the description in. But this is a huge benefit to be able to pick up a project when they go away, or check what's been done last time. The added benefit with any of this, it's like an added insurance with the rollback. If you ever need to go back to a previous version, the rollback functionality in our limited use of it worked fine. So we hope that continues. But it's a great insurance scheme. So in addition to the 12D model data, 12D Synergy is also managing our emails across the project. One of the key benefits of this was the ability to integrate the system into the Oricon and WSP Parsons Brinckerhoff Outlook Exchange service without the need of IT or changing our email addresses. The install simply integrates a 12D Synergy add-in into the Outlook, and it gives the ability to file the emails and search for them. So on the project, we've set up a couple of custom attributes within Synergy. So when a user sends or receives an email, depending on their setup, they get prompted to file the email. And we have two mandatory fields. One's an area and the other one's a discipline. So the user gets to file the area, whether it's a central, east, west, local roads, and then a discipline. They're all drop-down lists, so you just pick from what the discipline is. We also added an optional field there, and that basically just allows the user to define a further field to narrow down the search field effectively. This attribute tag of area and discipline allows us to then easily filter and group our emails within the 12D Synergy client. Fully searchable, so you can actually search down where you want, and currently we have over 14,000 emails stored within our Synergy, so it's been working well. An added benefit of obviously storing our emails in there was the ability to set up different group policies. It might be a bit hard to see, but on the left there, we've actually got a commercial folder, and this is locked down to only the commercial executives, but it gives them ability to file away sensitive and commercial information. Managed folders. So managed folders were used extensively on the project. Now, they weren't initially started out in there. We initially got our 12D data and our emails into Synergy, but soon realised the benefit of managed folders. So WSP Parsons Brinckerhoff web application called Sitemap is used on the Toowoomba Second Range project to collate, publish existing and design data, allowing the greater project team to visualise the project in multiple layers of information. The application is a custom built based on the ArcGIS platform and has multiple folder and file formats. So as you can see here, it's crazy the amount of different file formats and databases that they have. On previous projects, our GIS team have never been able to work in a document management system. They've just got too many files, and it's too hard to track down what has changed. So they've had to always store the information on a network, and that most likely is in our home organisation. So they've been detached from the project office, if you like. 12D Synergy's managed folders has allowed them to sit in the project office, so it's a huge benefit to be able to wander up to the GIS team and get them to make any adjustments to the sitemap. We also store our Navisworks and Civil 3D folders in our Synergy server. Now, Autodesk Navisworks was used to visualise the different design elements with all the disciplines. So we've got our earthworks, drainage, our roading. It just gives the engineers an ability to actually visualise the project outside of a 12D model. We use Civil 3D on the project, interface with our borehole database, and produce geotechnical outputs. These software platforms rely on a variety of different formats, and which managed folders are able to handle. XP Swim I don't know a lot about, but I understand that on the project it models the hydraulic requirements of the culverts by simulating various rainfall events and accurately determining catchment runoff, accounts for storage within the catchment, and model cross-drainage flows. The Swim model files are a combination of multiple files, folders, and database formats, which again 12D Synergy was able to handle with managed folders. So again, something that a software platform that we would have stored on the network previously has really given us the ability to have resources across multiple offices. Now, when it was all on the network, that was impossible to do. You would have had to have zipped up everything and sent it to them. So 12D Synergy has helped this project manage all the 12D model data in a secure and centrally located data source that's accessible by both Oricon and WSP staff. This has allowed resource sharing to occur seamlessly without the troublesome copies datasets or slow network connections. 12D Synergy has safely managed the data integrity across all software platforms stored in this database, with the added ability to retrieve previous versions if required. It's also allowed us to have a fairly structured workflow, so clean and simple sharing between our different platforms and different disciplines with the use of static and live design projects. Other benefits of 12D Synergy have seen the reduction of our continuous network traffic and improved desktop operations by working off our local drives. Sensitive and commercial data has been locked down from the wider project group as required. And it also allows us to use we've also used the custom attributes, if you like. So we use it in a couple of ways. One is a model version attribute that's added to the 12D model project. This attribute's passed through the 12D model data and drawings, so allowing the wider team to identify what the current version of the project, the 12D model project is, and the status of the design. And as discussed previously, we also have the attributes of area, discipline, and an optional field on all our emails filed. So a bit of a project summary. The Toowoomba Second Range Crossing project is still finalising the design phase, with early construction processes already started on site. When the project is finished, it will provide a vital expansion of the National Land Transport Network and will provide a safer, faster route for connecting freight to major ports. The local Toowoomba community will also benefit from the removal of the heavy vehicles from the central business district. 12D Model and 12D Synergy are helping the APB TSRC joint venture deliver some of these benefits to the community. A big thanks goes to the Toowoomba Second Range Crossing design team. Some of who are with us today, we've got about 6 in the audience, so Brendan Rutter, Brett Whitmey, Nathan Walden, Ivor, Litke, Ben Brown and Jonathan Foster. So without the design team, you know, these projects don't go anywhere, so a big thanks goes to the actual guys working on it. So thank you.